Okay, in this video, we're going to be doing Calc AB problem set 10. There's a link to the problems in the description below and also a link to all of the problem sets. So, or a playlist of all the problem sets. I can never say that part. I should just rewrite it. I have like a little script that I say. I should rewrite that part so that I can actually like deal with it. All right, we want to find dy dx for, this looks like a quotient. So we're going to use the quotient rule, and then we're going to use the chain rule everywhere we need to. So we're finding the derivative of the quantity 2x minus 5 to the fourth all over the quantity 5x minus 3 squared. All right, so quotient rule. I should have color-coded this, but I didn't, which is part of like saving me time. I'm trying to get all of these done in under 10 minutes for the entire year. So bottom is going to be 5x minus 3 squared. Derivative of the top, 4 times that thing's cubed times the derivative of that thing minus top. Derivative of the bottom is going to be 2 times that thing to the first times the derivative of that thing all over the bottom squared. All right, so once you get to this, so that's to the fourth, by the way, and I see a lot of people make this mistake. The denominator is already squared, but we have to square it. It's like whatever is in the bottom, we're going to square it. So it was 5x minus 3 squared, which led to it being to the fourth. This type of problem with the quotient rule will always end up with a group factoring situation in the numerator. So I'm going to look through the numerator and take out the greatest common factor, which in a previous video I couldn't remember the name of. So I'm taking a 5x minus 3 out and a 2x minus 5 to the third out. And then I have 2 times 4 is 8, and I still have a 5x minus 3. I have 5 times 2 is 10, and I still have a 2x minus 5. All over 5x minus 3 to the fourth. Look, the 5x minus 3, there's 1 in the numerator, and now there's 4 in the denominator, so I'm going to cancel one of those, and then I'm just going to kind of like expand that thing. So I'm canceling the 5x minus 3 in the numerator with one of them in the denominator. And then this becomes 40x minus 24 minus 20x plus 50 over 5x minus 3 to the fourth. There's nothing left to do except clean up there. So let's clean it up. So 2x minus 5 cubed. I mean, this is like a straightforward problem, but it is worth practicing. Like, you're going to have to do problems like this. They're a little messy, but they're not really that bad. You could take a 2 out of 20x plus 26, but I don't think it's worth it. I mean, do it if you have to, but I don't think it's worth it in this case. All right, next problem. Identify the discontinuities of y equals 3x squared minus 11x minus 4 over 2x squared minus 5x minus 12. All right, so we basically need to factor the numerator and the denominator because a removable discontinuity will be a factor of the numerator and the denominator, and a vertical asymptote will be a 0 of the denominator that doesn't cancel out. So let's see what we get. So the numerator, I'm going to go with 3x and x, and then I think I want to do plus 1 and minus 4. The denominator, I will confess, I couldn't figure out how to factor it first. So I had to like actually factor this thing. Like I know it has to go 2x and x, right? But sometimes I run into them and like I can't figure out how to factor them. So I do it the long way, right? I need numbers that multiply to negative 24, that add up to negative 5. I look at that and I'm like, oh, negative 8 and 3. Okay, so then I rewrite it as 2x squared minus 8x plus 3x minus 12. Then I group factor this thing and take a 2x out of the first things, and I'm left with x minus 4. And at this point, I know how to factor it. Plus 3, and then there's an x minus 4. And then I would take out x minus 4 and be left with 2x plus 3. So 2x plus 3, x minus 4. Sometimes I run into them. I got to do the work. I think that's totally acceptable. All right, I look at this thing. X minus 4 shows up in the numerator and the denominator. So those can cancel. So that's a removable discontinuity. So we definitely have a removable discontinuity at x equals 4. And then we also need to consider what's happening with the 2x plus 3. 2x plus 3 is a factor of the denominator that doesn't cancel out. That's going to give us a vertical asymptote wherever that thing is 0. So there's a vertical asymptote at x equals negative 3/2. So be on the lookout for things like this where questions like multiple choice questions will say like how many removable discontinuities or how many vertical asymptotes or like how many asymptotes does this thing have? You have to know the types of discontinuities to really be able to answer those questions. Next up, use the very well made graph. You can see I did all the graphs pretty much by hand on this because like I'm trying to do these quickly so that people have the problems to do, but it's not taking up all my life. So I'm doing them mostly by hand, and it looks fantastic. So use the well-made graph above to find the following limits. So We want the limit as x approaches 4 from the left of f of x. So this is like a classic, right? You just approach 4 from the left. You can see that you're going up to infinity, so our answer is infinity. 4 from the right. So you approach from the right, and you see that you're going down to negative infinity. Now we need to approach 6, so there's no plus or minus, which means we have to go from both sides, and we have to get the same answer both times. So from the left, from the right, you can see they're both going to the same thing. I forgot to put a scale on the y-axis, so I'm just counting by ones. So that's going to give me x equals, not x equals. The limit as x approaches 6 of f of x is 3. That's the value you would expect. Don't get fooled by that point that's there, right? The actual value of f of 6 is going to be 4, but we don't care about that. That's not the question. The question is, what is the limit? All right, we're going to approach 8 from the right. So 8 from the right is going to give us negative 3. If the question had been the limit as x approaches 8, the answer would be does not exist, because the limit from the right is negative 3. The limit from the left is negative 1. Those do not equal each other. So watch out for that. The answer could be doesn't exist. Doesn't have to have a limit. And then we want to approach 12 overall. So there, you're definitely approaching 1, 2, 3, 4. So that answer is going to be 4. All right, there you go. That's the end of this problem set. I'll be back in the next one to do the next problem set. I hope you found this helpful, and good luck.